right, my friends. So this is a combo of a help video and a little bit of Funny Story Friday, all wrapped up in one. So I think most of you know that I had a little bike accident and ended up dislocating my elbow. And so at this time, I've realized that writing with my dominant hand, which is my right hand, where the splint is not going to happen because the splint goes too far out. So here's that. Anyway, so it goes too far out to be able to hold a pen and write with it, which I think is on purpose because every time I try to use my fingers, it actually hurts my elbow. Anyway, I don't think I'll need to have this splint on for long, so that's a relief. But here I am, and I'm stuck with my left hand, which is not my dominant hand. And so I just thought, I've been typing the solutions, and I think maybe students are wondering, why is she typing them? Anyway, so this is going to be a help video for problem 9. And this is on section 9.3. Oh my goodness. Anyway, you gotta have a sense of humor in life, or or just not gonna have any fun. Anyway, if you needed help with this problem, then continue watching, but you've probably seen the gist of it at this point with my handwriting, which, by the way, has come a long way. Here's what it looked like. Well, actually, no, it hasn't come a long way, but here's what it looked like, the other day when I tried to to do a problem. Anyway, so I am just having just a ton of fun right now with laughing at myself. Anyway, if you are watching this video for because you actually wanted help with this problem, then because I'm writing so slow, I would not have my feelings hurt if you decided to, watch this on 1.5 speed or double speed. You'd probably be really happy with yourself if you did. All right, so if x is 2 cosine theta, then what's dx d theta? It is negative 2 sine of theta. Okay, and then dy d theta. Oh. Oh. Hey, but the good news is, so I think my son's left-handed, and so now we can practice our letters together. Anyway, derivative of sine is cosine, so we'd have 2 cosine theta. Okay, and then we'll do dy dx, which is the easy part. So dy dx is dy d theta divided by dx d theta, so that would be 2 cosine theta divided by negative 2 sine theta. All right, how are we doing? Okay. I'm going to go ahead and simplify this, let the 2's cancel. Or we'd have sound effects being the sound of me falling off right after I fell off my bike. I'm okay. Ooh, I'm okay. Anyway, so those are my canceling sounds. All right, cosine over sine. What's that, cotangent? Okay, there we go. All right. So there we go. There's dy dx, and then we could go ahead and get dy dx. They said they wanted the slopes at the value, I think theta equals pi over 4. Okay. So that would just be negative cotangent of pi over 4, so negative 1. There we go. Okay. Now for the second derivative, so can you just pretend that that says d squared y and then over dx squared? Okay. So conceptually, that just means d dx of and y, so d dx of dy dx. There we go. Okay, so then that is equal to, I'm going to do a run-on sentence here. That is equal to d dx of, and then dy dx is negative cotangent theta. Okay, so we're taking the derivative with respect to x of cotangent of theta, and theta is a hidden function of x. And just a quick review, if up here you were to solve for theta, you would have theta equals x over, the arc cosine of x over 2. So if x changes, it makes theta change. So therefore, theta is a little hidden f of x there. So we'll just have to use chain rule when we take the derivative and a little implicit differentiation. So let's see, derivative of cotangent, is that cosecant squared, negative cosecant squared? So, so we'd end up with positive cosecant, yeah, I think, positive cosecant squared theta. But then times the derivative of the inside function, so times d theta dx. Little chain rule. Sneaking up on us. Okay, so then, what's d theta dx? I don't know. The closest thing I have is dx d theta. So that I can use dx d theta, I'm just going to flip and divide. My goodness. That's supposed to say cosecant squared theta divided by dx d theta. All right. Okay. And then dx d theta, we could substitute negative 2 sine theta in for it. Negative 2 sine theta. Okay. And then, okay. And then cosecant itself is 1 over sine. So if you were to simplify this, you would end up with either negative, or 1 over negative 2 times sine cubed, also known as negative 1/2 cosecant that's supposed to be a 3 theta. Oh, okay, all right. So so this is the second derivative of y with respect to x. Okay, and now for the concavity at pi over 4, so that would be oh boy, that's supposed to say theta, and that's supposed to be an equal sign. Maybe this is how new math notation gets invented. All right, so now we've got negative 1/2. And then just, so cosecant cubed is 1 over sine cubed, so I'm just going to do 1 over, and then the sine of pi over 4 is root 2 over 2. And it's getting cubed. And then let's see. So then this would equal -1/2. And then, so if you flip and multiply here, you'd have 2 over √2, and then you could cancel that down and it could just be √2, so. But then I haven't cubed it yet. So if you cube this √2, you'd get 2 √2, and then the 2 would cancel with this. And so your concavity of this graph on an xy plane at the moment where your angle is pi/4 is equal to -√2. All right, my friends, there it is. Happy Funny Story Friday. Feel free to contact me, send me some comments if you have any tips for how to learn how to write with your left hand. Anyway, hopefully it'll be short-lived, but here you have it. Anyway, take care, everybody. Happy Funny Story Friday.